Imagine walking into a busy cafe. You hear the hum of conversations, see the vibrant decor, smell the rich aroma of your coffee, and feel the warmth of the cup. Humans naturally integrate different sensory inputs to understand and interact with the world. Multimodal AI strives to do the same, but for machines. When you chat to ChatGPT, it understands that red is closer to orange than blue is. But learning about the world through text alone, that's slow. Images, on the other hand, provide a faster way to understand and learn visual relationships. And for this reason, text and vision are key components for multimodal AI. So let's see some models in action. Google's Gemini 2 model is designed from ground up to be multimodal. The Gemini app gives you access to 2.0 models, all of which are multimodal. They process audio, text, images, and even videos, but only YouTube videos. However, the app itself doesn't support direct video input or output. I tested it by sending some random images and asking questions about them. Hey Gemini, what is this tree and can it cause allergies? It not only identified the species but also provided information on whether they could trigger allergies. Next, I pushed it further. I uploaded an image and asked for as much details as possible. The response? Impressive. It extracted numbers, text, and even architectural styles. And that's not all. Gemini is also integrated with YouTube, Maps, and Search. I tested it by asking questions about my YouTube channel. It didn't just summarize each video, it went further. When I asked where residual stream was discussed in a video about residual learning, it returned the exact timestamp with a direct link. In Google AI Studio, you can access Gemini models that also have video modality. Let me demonstrate. So we can start a video stream with Gemini. Hey Gemini, can you see me?
Yes, I can see you.
Hey Gemini, do you know what is this album?
Yes, the album you are holding is Taylor Swift's Reputation album. Is there anything else you'd like to discuss about it?
How many fingers do you see?
I see 2 fingers in your hand. Okay, so you're thinking of a game for kids aged 4 to 5 where they hear a phonics sound like P and then have to identify an object that starts with that sound. That sounds like a fun way to help them learn their phonics. Okay, let's test it out. This sound I choose is K. What object do you see in your background that starts with that sound?
Keys.
The piano keys are a great answer.
Hey Gemini, can you see my screen that I'm sharing with you?
Yes, I can see your screen.
Can you read the title, please?
The title of the document is Gemini 1. 5. Unlocking multimodal understanding across millions of tokens of context.
Great. Can you give me a 2-sentence summary of what this paper does?
This paper introduces Gemini 1. 5. A new family of multimodal models from Google DeepMind that can process millions of tokens of context, including text, audio, and video. These models can also perform tasks like long document question answering and translation with high accuracy.
Apple is making big strides in multimodal AI, pushing boundaries with such models as MM1 that show impressive capabilities thanks to large-scale multimodal pre-training. In their paper published in 2024 called MM1 Methods Analysis Insights from Multimodal LLM Pre-training, they show that their model can count objects from images and follow custom formatting. It can also extract text like Hyde Park from this bus image and show common sense knowledge about everyday objects like refrigerator where it infers its weight, for example, and do simple math from images. They prompted model with 2 images, one with a berries on the table and another is a menu with prices, and asked the model to calculate the total price to be paid. And the model returned 12, which is correct answer. Simple? Yes, but for AI models, this level of reasoning across modalities is a huge thing. And here is the exciting part. You don't have to wait to try Apple Multimodal AI. It's already accessible through Apple Intelligence. Take Genmoji for instance. I said, I'm feeling sunny and like eating ice cream today. Then AI created custom emojis reflecting the vibe. Or image playgrounds. I gave it the prompt, a giant rainbow colored elephant eating ice cream in Gothic style. And just like that, it generated images on the fly. Then there is a photo search where I simply asked for lakes in London and it quickly retrieved relevant images. And one of my favorites, image wound. In the Notes app, you can start with a rough sketch, then let AI refine it into a polished image. All of this running on your mobile phone. Apple proves that high-performance multimodal AI isn't just for research labs or big companies, it's already in your pockets. If you want to build applications using multimodal AI, you can of course use Gemini models and GPT for vision, but also there are open source models. Let's check out what's out there. To quickly understand which models are performing best, let's take a look at the MMU Challenge leaderboard. MMU has become nearly an industry standard for benchmarking multimodal AI models. It provides a comprehensive overview of model performance across various challenges. The MMU dataset includes 4 key challenges: comprehensiveness, with 11.5K college-level problems spanning 6 broad disciplines and 30 subjects, a wide variety of image types, a mix of interleaved text and images, and expert-level perception and reasoning requiring college-level subject knowledge. Models are typically evaluated in zero-shot setting, meaning they are tested without fine-tuning on specific examples from the MMU dataset. Scoring is based on the accuracy of the model's predictions across the entire dataset, calculated as the percentage of correct answers. As you can see, along with human experts, there are 2 OpenAI models, O2 and GPT-4 Vision, that are available for Plus users. And also there are Gemini models and a model from Chinese company Spark 4.0 Turbo. The first open source model on the leaderboard is QVQ with a score of 70.3 on MMU. Developed by the Quen team, this experimental model focuses on enhancing visual reasoning capabilities. It has shown impressive results, achieving high scores across 4 different benchmarks. One thing that caught my attention when visiting the QVQ homepage was the list of limitations and warnings. It's a small detail, but it reflects the Quen team's responsible approach to their work, which in turn fosters trust in the model. If you're curious, you can check out the demo on Hugging Face. I tested QVQ using one of the MMU examples where GPT-4v struggled. The question asked whether the FDA is minimal. While GPT-4v didn't succeed, QVQ reasoned through the problem carefully and after thorough analysis correctly concluded that the answer was yes. Impressive, right? I really appreciate how it takes the time to reconsider its reasoning and challenge itself, ensuring the conclusion is accurate. The next model on the leaderboard is InternVL, which scores 70.1 and has the same 78 billion parameters. I tested it using the same example and it also returned the correct answer. However, the reasoning was much shorter, more structured, and lacked the self-challenging pattern seen in QVQ. Interestingly, it seemed to reach the answer more quickly. In another test, I asked it to generate Python code from a flowchart. The model performed excellently, showcasing its strength in translating visual information into code. In March this year, DeepMind introduced Gemini Robotics, a model that adds action as a new modality. This means that robots powered by Gemini Robotics can work in different environments, work across different robotic platforms, and understand natural language instructions instead of predefined commands. And intricate tasks like folding origami is within reach. Then there is music from images. Refusion creates completely new music from spectrograms. Another interesting example is Osmo, that maps scents, bringing AI into the world of fragrance. A different modality that companies like Neuralink can explore is mapping brain signals to digital vision and speech. And these are all examples that AI is expanding beyond just speech and vision. We are still in early days, but the future is exciting.